Morning. This morning we are going to look at surface area of objects with right rectangular prisms. So I'm going to kind of be doing this with my document cam so I can kind of show you things. So hopefully it comes across, and I might have to move a little bit slowly so things don't freeze. So what you should be able to do in this unit is determine the surface area of composite 3D objects in order to solve problems. What essentially that means is we're no longer just going to take an image like a Kleenex box, but we are going to take a Kleenex box and we are going to stack a cylinder on top of it and then ask you a question like how much wrapping paper would we need to wrap the objects together? So what is surface area? So this is notes from when we had done it as a class. So the area of each individual side added together will give us the surface area. So it's something like how much cardboard would you need to build the box? So there's lots of different formulas that you need to remember and know. So for a rectangle or a square, area is base times height. For a triangle, it is always area is base times height divided by 2. For a circle, you should remember that the area of a circle is pi times radius squared. So if our radius was 3 in that picture, it becomes pi times 3 times 3. Or if we're asking the circumference, it is pi times the diameter. In this case, it would be pi times 6. Now, using those, we can build the formula for a cylinder over here. 2 pi r squared because we have 2 circles, and adding pi dh because the circumference times the height of our cylinder will give us our entire shape. So this is an example, reminder of last year. So last year, you would have got an object like a Kleenex box with dimensions. And in order to solve it, you would solve them each individually. So area is base times height, 2 times 4, which equals 8. Now in this shape, the front and the back are the same. So I'm going to times it by 2 to get 16. Then base times height is 2 times 6, which is 12. These are my 2 sides. Once again, because there's 2 of them, I times it by 2, which gives me 24. And then the top and the bottom is base times height, 4 times 6, which is 24. I'm timesing it by 2 because there's the top and the bottom, which gives me 48. And then to figure out the entire surface area of the whole thing, I'm simply adding together 16 plus 24 plus 48, and that gives me 88 centimeters squared. So this year, we're going to be working a little bit with 3D objects. And your class did a lot with these cubolinks. So the first example says to make a shape with 4 cubolinks. So if I were to simply just stack my 4 cubolinks together, and they look like this. Okay, each face of a cube has a square of 1. So this is 1. Okay, a 1 by 1, which is 1. Method 1, count the squares faces of all the cubes. Now subtract 2 faces from each surface where the cubes are joined. So essentially, if I know that one of these cubes is a 1 by 1, and there are 6 sides that are the same, I can say the area of this entire cube is 6. So this is 6, this is 6, this is 6, and this is 6. 6, 12, 18, 24. So my area is 24. However, when I join these two together, I am losing the bottom of this red and the bottom of this blue. So I'm actually subtracting 2. So 24 minus 2, I'm at 22. When I join these, I'm once again losing these 2 sides because they are covering each other, so I do not see them anymore. Now I'm at 20. Joining these 2 sides, I'm losing 2. I'm at 18. So the surface area of this object is 18 units squared. Now, the second method that you can work with is to count the squares on each of the 6 views of the shape that you created. So once again, we would be looking back to last year when we had the top, the front, the side views, and we would just take our shape and actually just count what we see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, now if you don't physically have the object in front of you, it's hard to actually just count because you may miss something, or you can kind of improvise with what you have. So what this leads us into is to problems that look like this. Determine the surface area of a composite object made from right rectangular prisms. So in this case, we took 3 separate Kleenex boxes and we stacked them on top of each other. She uses 3 boxes to make a shape. Each box is a right rectangular prism with the dimensions 60 by 20 by 20. What amount of wrapping paper would it take to cover the shape that she created? So for this object, you would say area is base times height is 20 times 20, which is 400. And that would be the ends shapes right here. Now, because I have 3 of these boxes, I have 1, 2, 3, 4, 5, 6 ends multiplied by 6, which equals 2,400. Okay, so this is the sides. Okay, then base times height, 20 times 60 equals 1,200. Now, my 20 by 60 is my top and my bottom, but also my front and my back. So I have 1, 2, 3, 4 on this shape, 8, 12. 12 in total, multiplied by 12, which equals 144, or 14,400. So if I take that answer and I add the area I found for the first one, my total is 16,800. Now, just like with the cubolinks, when I stacked these together, I lost some sides. So I lost 800 because I lost 1, 2 of these little sides, right? I lost this one and the matching side of it over here. So one of them is 400, so 2 sides would be 800. Then when I stack this one on top of this one, I also lost the bottom of this top one and the top of the bottom one. So if one of them is 1,200 and I have 2 of them, I'm losing 2,400, which gives me 13,600 centimeters squared. Okay, here's another example that I'm not sure that you have on your screen, but we did as a class. So because I'm not artistically talented at drawing, I drew them separate, and then you just had to pretend that I stacked one on top of the other. So for the first shape, it is a cube. It is a 3 by 3. So base times height is 3 times 3, which is 9. And a cube has 6 sides that are all identical. So I times it by 6 for 45. For the second shape, because it is a rectangular prism, I have to do the formula 3 separate times. So 2 times 3 is 6, and there's 2 of them, so it's 12. 2 times 5 is 10. There's 2 of them, so it's 20. 3 times 5 is 15. There's 2 of them, so it is 30. And then we're also going to do that same thing for this bottom shape. Once again, rectangular prisms, 3 formulas. Base times height, 4 times 5, which is 20. There's 2 of them, so 40. 4 times 9 is 36. 2 of them, so 72. And 5 times 9 is 45. 2 of them is 90. After you do that, your next step is to add them all together. So 45 plus 12 plus 20 plus 30 plus 40 plus 72 plus 90. And that gives us 309. Now, that would be done if they weren't stacked together, but because we are stacking them on top of each other, we need to remove the parts that disappear. So when I took this object and I stuck it on top of there, I am losing 3 times 3, which is 9, so the bottom of this shape is 9, but I'm also losing that same space from the shape underneath it because it's covering it on here. So I need to lose 18. When I stack this shape on top of this one, I'm losing the bottom of the shape, which is a 3 by 5, which is 15. But I'm also losing the equivalent distance on the one underneath, so I'm actually losing 30. So 309 minus 18 minus 30 gives me a total surface area of 261. Questions like this would be out of something like 11 marks because of all of the steps required in order to solve them. Here is a third example. Again, you're solving each of them individually, adding them all together, and then you are just removing the parts that aren't there. So in this one, after we had done stuff, we did add in the doors and the windows. Because you're going to see questions that have you working in problem solving mode. And that would mean that they're going to ask you in the end how much paint you would need to paint the exterior of this building. So if you're doing something like that, you would also have to subtract the doors and the windows from your final answer. More than likely, you would have to subtract the floor. You may have to subtract the ceiling depending if they tell you what kind of roofing they have. So again, you're just showing all of your steps, and after you have solved everything, then you deduct the parts that go away. So there is a lot of questions for this one. I didn't provide all of them here, but even where the ones that I did provide, there's lots of work in there. This is one of the sections that it is important that you take your time to try and answer as many of the questions as you can. Practice is the only way to fully master this section. Good luck.